Hi guys, and welcome back to Wade's Workshop. So it's been a little while since I put a video up. I haven't been in the shed very much at all. Summertime, there's always something going on most weekends, work all week, that sort of idea. And getting the opportunity to come down the shed has been quite sparse at the moment. What I have been doing, I've got most of the electrical components, and what I've been doing is trying to set things up, or temporarily set things up, just so I can see how it all goes together wiring wise, so that I can make all the connections, make the right length cables to do what will then be a tidy job of putting the electrics together at a later point. I've never used an inverter before, so I've had a bit of fun trying to figure that out, looking through the manual and setting various parameters, that sort of thing. But it's pretty sort of intuitive once you get going with it, and I've got it all working. So what I'll do is show you where I am. Oh, one other thing that came up. I just bought this 12 volt, I'll show you this afterwards, a 24 volt DC to 12 volt power supply, converter basically. So I have a 24 volt power supply in my main box, and as it turned out, the RPM counter runs on a 12 volt supply, 9 to 15 or something like that it is, and I didn't have an available supply to power that. So basically I'm going to take the 24 volt DC, run it through a converter into 12 volt DC. So yeah, just a little box. It was like, you know, £5 or £6 on Amazon or eBay, and I will then have basically a 230 volt supply coming into the unit, a 24 volt power supply running off that, which powers all the stepper motors and all the rest of it, and the stepper controller. Obviously I've got the main inverter unit, which takes 230 as well, and all its outputs appropriate to running the three-phase motor. And there's various sort of signalling wires to control remotely from the inverter on the lathe, so I haven't got to stretch up onto the wall where the inverter is. It's all there on the lathe in a convenient position. I'll show you what we got, guys. So I got stuff everywhere, as you can see, but I've got it rigged up. So this is, I've disconnected at the moment. 230 volts coming in, live neutral earth, into the bottom of the inverter. I've got it upside down as you see it. I've run a ground cable back off the ground from the inverter onto the body of the motor. I don't need to do that, but well, I want to do that, so it's there. But it doesn't say anything in the instructions about it, but it's there anyway, going to the motor. And then of course it uses the terminals on the motor, L1, L2, L3, and it's the old school red, yellow and blue, as opposed to the brown, black and grey, which seems to be the more common nowadays. So these are the three lives going out to the motor from the inverter. I've run an earth or ground, and that's a 230 in. So into the inverter, and the supply to the motor back out on these four wires. So I'll go to the motor next. So as you can see, three phases coming in, matching up the colours in here. It's all switched off, it's isolated from the wall at the moment, and the ground onto the body of the motor. And I will be linking all the grounds, the frame, everything at a later date, just to give myself a good ground to earth into the power supply of the shed here. So let's go to the control side of the inverter. So first thing, I'm using the original RPM pot potentiometer that was on the mini lathe, and that works. It does actually work. Now there are three terminals in here marked up on the wiring diagram, which shows the central wire and the two either side all lined up, so that works. So basically I will be extending these wires or resoldering some new ones in anyway, but I know the connections for those, and that works. So the next thing we have is a common output source. This first wire, I believe it's something like, I don't know, 12 volts, let's say, for instance, 12 volts positive. Now there are three returns here. One is to initiate forward movement. The second one to initiate reversing of the chuck, so basically on off. So if I connect this one to here, it'll start in forward, connect this one to here, it starts in reverse, and the last one of all, well in fact I think this first one, so forward and reverse up here, and the first one I've got in here is emergency stop. So I'll show you the sort of slap together bits and pieces that I've got that I'm running pretty much over here, just as a mock-up to get it all working. But this is by no means a final wiring setup. Okay, right. So, having moved across, we're going to come on to these at a later date. They're going to be for the 24 volts switching. So, the common wire comes up here, and I'm running it to the center of this double pole switch. So when the on-off switch, the original on-off switch, again with these 12 poles, when I go the one way, it connects the output to this one, which sends the signal out to start in forwards, and when I flick the switch the other way, it sends it out the second wire, which basically goes straight back to the inverter and starts it up in reverse. And of course, final thing, I have got this emergency stop. I've had to change it. I've got this emergency stop button online again. So one side of it is normally open and the other side is normally closed. There's a reason for that, because what I want is when I push the emergency stop, I want it to stop the motor, and I also want it to break the power supply or the enable for the feed motor as well. So if I push the emergency stop, it cuts off everything, yeah, which is what you'd expect. One good thing that's come up is that when it's running, if I push the emergency stop, basically sends a signal to the inverter to stop, and it stops. However, if I release the emergency stop, my worry was that it would start back up again. I didn't want that to happen, but it doesn't. You've got to actually switch the main on-off power switch off, then back on, and then it will start. So that's everything's working as I wanted it to. I was a bit worried about how that was going to work, but it turned out good in the end. So yeah, if I just switch it on the wall, now this is purely the motor system here. So I just heard the inverter start up, so I'm making sure there's nothing catching. Now we're all good. So if I start it up in forwards, I've just got it on a slow speed to start with. In fact, that's reverse. Something's making a noise there. What is that? I haven't got the belt on straight. Okay, but that's not to worry. So that's forward, and then if I flick the switch the other way, nice slow start. I've set the acceleration, all the rest of it, and we're running in reverse. Okay, so if any point now with that running, let me just do that, I push the emergency stop, it stops. If I release the emergency stop, it doesn't start up again, which is what I was just referring to. I've got to switch off and back on again. Then it starts up. And of course, I got the potentiometer here. I can change speed. I've just set the max speed quite slow for now, and I can slow it right down. Okay, and if any time I want to stop, just switch it off. Well, there we are. That's the motor side of it done. You know, the motor control side. I will play with the parameters, set up braking speeds for the emergency stop, set acceleration times, deceleration times. There is a booklet that came with the inverter, and pretty much everything's in there. It's quite simple to do. Programming, I'm not going to be able to do that remotely. I'll do all that on the control panel. I mean, once I've set it up, it's not going to be touched very often. We no need to put that on the lathe. But basically, there's a few parameters, things like the original potentiometer on here. There's a setting within it. You go into the function, get the right one that refers to the variable speed, set it to an external source, and then when you connect up the pot, that works. And exactly the same with forward and reverse. It basically replicates out externally to the unit the controls on the lathe itself, or what are going to be on the lathe. So yeah, just rig this up. It's rough, it's ready, but just to see what's needed and what works, and so I've got an idea of what wiring I'm going to need and all the rest of it. So, problem I got, originally stop was a bit of a built-up unit, and this one needs to sit in there like that, which is a bit of a pain because I got a square hole and a round peg. So just make up this little plate. I've just marked out where the two holes go. So that little plate's going to go on there. Once it's in, I'll drill a hole through there, the right size for that. We'll have somewhere to mount the emergency stop. Hence, part and parcels of the reason why I'm not painting any of this at this stage. Few more things to fit. While I got this clip going, let's just show one more thing. The 12 volt conversion. Let me just check the camera. Yeah, you can see where I am. So the 12 volt power supply, that's going to get screwed down into the bottom of there, which is out the way. I've checked it, I've put it in there, basically whacked it back on the lathe, had a look through the window here, everything's clear. So yeah, that's going to go by there. So yeah, I'm trying to keep as much of the electrics in this box as possible, the lathe electrics, feed everything into here, and then it'll be one sort of set of wiring controls from this box through the various holes in the bed. I think you can see them, you know, with some protection, and then out to the motor, and then out to the controllers on the wall, as it were. So yeah, it's coming along. A couple of holes in here, a couple of screws in here now with a bolt or two, a couple of bolts through there. This power supply does need its output ground, which is, let's have a look, that's in, that's out. Output ground is that wire there. That does need that attaching to ground, so I'm going to run a ground or a earth wire onto the tab on here. I'll give this a scratch, and also run this one onto here, and then bouncing off to the negative supply for the unit. So yeah, and this will be 12 volts in. This will be basically supplied from the 24 volt power supply, and it has got its own little fuse, so that's happy days. Doubt that fuse will ever go, but yeah, because I'm only running that tiny little clock on it. But yeah, anyway, happy to have it there. So just marked and centre punched the little plate. I've checked, I'm missing the bed. Okay, so that'll be the hole for the 2 screws. Need to find some M3 screws that are going to be long enough now. So that's the e-stop in position now, and the little on-off switch does still fit. It's quite close inside, but it does still fit, so that's the mechanical part of that bit done. Need to mount that in the bottom now, so that's just drill a couple of holes, spot them through. Yeah, so we'll get on, do that off camera, and yeah, we're getting there, guys. We're getting there. So I have a switching power supply. I've bought it in for another project. But that's by the by, we won't go into the detail of that now. Anyway, I've set it at 24 volts output, just minimal amps. I don't think it'll tell me what it's drawing, but yeah, obviously I can set a max, but it's only drawing 0.06 amps. So the other end, let me bring you across. So the other end is connected up via the red and black here onto the input for the power supply, the 12 volt converter or transformer, whatever we want to call it. And if I probe here, my multimeter is saying 12.13. Oh, can I do that and show you? Let's see. We're only talking low voltages here, guys. Let's have a look. Oh, come on. Not connecting. Come on. Well, it was a minute ago. 12.13 volts. I haven't got it. I'm not enough pairs of hands. There you go. Right, okay. So I'm happy now that this regulator is outputting the correct voltage for my RPM counter, so I can now connect all that up, and we'll see where we go from there. So I've got the power off at the moment. The brown and the brown wire, or this cable, let me explain. This cable has a black, a brown and a blue. The black is the signal wire, which connects to the yellow, which plugs in the back of the display. The red wire connects to the positive, which goes to the display, and the red wire and the brown wire is the positive for the counter. Again, the blue is the negative and the black going to the display. So I've connected all that up. So I'm going to spin it around now so you can see the display. And theoretically, if I turn it on and turn 24 volts on into here and turn the spindle by hand, I should get some sort of reading. Let's have a look, see if we do. So moment of truth, power supply on. Click. Oh, right, we have a 0. So if I'm going to rotate the spindle by hand. Come on. Ah, there we are. Got the magnet round. And I'm just rocking it back and forth really quick in front of the magnet in front of the sensor. I'm not rotating, I'm just back and forthing. So I'll do it more slowly. I'll do it really slowly. Obviously I'm just rocking the magnet back and forth across the sensor here, so I'm doubling up. Right, I'm going to stop rotating, and hopefully that should go in a moment. Is there a bit of a delay? Is the magnet in front of the sensor? Come on, it's not doing 5 RPM, it's doing 0. That's better. There we are. Right, well, I don't know how accurate this thing is. I suppose when it's rotating constantly, there'll be a bit of a delay until it gives you a new reading. But yeah, that works. So at least I know, or now I know, the wiring configuration needed when I come to connect all this up as part of that system. So pretty much I've covered the main spindle, the wiring I need for that. I know what wires I need and where they need to go and the routing of those. And I've also got the display wiring. I know what's needed for that. Again, when I push the emergency stop, it's going to break the 24 volt supply. No, it's going to break the enable line. So I don't think it'll switch off the display. But what this will tell me is that I haven't switched it off on the wall. So it's nice to have that indicator light on there, so I'll know that when I leave the shed and what have you, that light should be out. I'll know that I've switched off the 24 volt power supply on the wall, yeah, and it's all done. I'm hoping to have basically one 13 amp plug to run the whole thing. It's 2 at the moment, but that's my plan going forward. But at least I'll know I've switched it off. So yeah, I mean, my little 24 volt, look at the mess. I got stuff everywhere, your wire cutters and God knows what. But yeah, so happy days. And it looks like it takes 0.07 amp. Interesting. If I set him to run, does that increase? Ah, marginally. I wonder if it needs more power. I don't know. So just turn the amps up to max. No, it's just drawing next to nothing. Okay, happy days. Now I know what wiring I need to do that part of the wiring. I can start to plan ahead with wire routings and what have you. So I don't know if I've shown this. I've done a bit of work in the box with a 12 volt, 24 volt power supply connected into the mains, or it will be when I put a plug on the end of it. Right, 24 volt runs to the stepper controller. Stepper controller needs to speak to the pulse generator, which is going to be at the lathe. I've made all the connections up into a multi-core cable, and this will be connecting up at the lathe end into this. This also needs 24 volt, so there will be a separate 24 volt. Let me make sure you can see. Yeah, you can. There'll be a separate 24 volt coming from the 24 volt power supply, basically out with these 4 wires. And these 4 wires here, I'm hoping I've got them long enough as it stands, are going to go to the stepper motor. And they're colour-coded to match up with the stepper motor, so I know I've got that right. So other than a 24 volt supply coming out of here, which goes to the pulse generator, and it will also go to that 24 volt to 12 volt converter via the emergency stop. I'm not sure if I'm going to do it via the emergency stop, so that killing the 24 volt stops the stepper motor, or whether I'm going to use the e-stop in the enable line. I think I may well use the 24 volt, let the e-stop kill the 24 volt supply to this. I think that's the way I'm going to do it. Anyway, so that said, that's that part of it. The only other thing, let me put that in there safe. Right, the way I'm going to lay out the inverter box, let me grab it, it's all out of shot at the moment. So this is rigged up at the moment. Oh, try not to bang the camera. This is rigged up on the moment, screwed onto the lid. You can see ball nuts and bolts, can you? Yeah, just about. Ball nuts and bolts screwed onto the lid. So this is going to sit, obviously, on top of there. And I've got all these wires hanging out on the top. So there is, underneath here, an opening. Well, I can't show you. But the bottom of this is hollow. I'm going to drill and grommet a couple of holes in this lid, and these wires are going to feed inside this box. Hold on. There is a rubber grommet that goes in there just to block that off. They're going to feed down in through and in through the lid onto a terminal block inside the lid, and then again at the other end, which means I can connect up the wires. So I'm going to mount a terminal block on the underside here so that this is a separate area and it can be just disconnected quite easily. And again, the power cable, the earth out and the wires out to the motor are all going to go down through here as well. There is room, there's a fan in here, but there is room to get them, you know, I might have to put two in and go either side, into the box, and another terminal block this end. Obviously one power supply at the moment, because I've been testing this. I got a plug on it. This will connect into the 230 in on the same terminals as the 230 in on the 24 volt power supply. So when you look at the front of the box, let me show you, can I show you? When you look at the front of the box as it's going to stand on the wall, all these wires that are hanging out at the moment, going everywhere, they've disappeared. They're going inside the main sort of control box. So I think that's, you know, that's what I've come up with. It's probably not brilliant. I did see a comment on another video. Somebody commented that they mounted this inverter on the wall behind their machine, and somebody said they should put the inverter in a box. I don't think so. I mean, it is an electrical box. It's designed to have airflow. It's got a fan underneath, comes in the top, out the bottom. I do need to put holes in my main control box because I do want that 24 volt controller to breathe as well. So yeah, before anyone jumps on my back, which I'm sure rightly so, but I am aware that, as you can see by the size of the heat sink, you know, and it's cooling holes and all the rest, and I do need air supply in here. So I will be putting plenty of holes in here to be able to allow this to dissipate heat. I'm not using anything like the 10 amps. I won't be using anything like the 10 amps of power available. As you saw, the driver, I think its amperage is maximum 3 or 4 amps is the most that driver's going to output. So yeah, it's not going to take a lot of current at all. If I'm using 4 amps out of the 10 available, I'd be surprised. Yeah, I could actually have a look and put the clamp meter on it or at some point and just see what amps I am using. But yeah, so it's not going to be running at optimum, but I will be putting holes in. I'll probably drill a stack of holes in the bottom here to let air come in. And again, some holes at the top as well, and I'll stand it off the wall. I might even put holes in the back. Series of like 3mm holes, but lots of them, maybe 4mm, but lots of them, just to let air in and air out. Holes in the bottom, holes in the top, because it's only ever going to rise and draw in colder air. So yeah, that's the anyone that says I shouldn't be shutting out of the box, that you're quite right. And again, the stepper driver is a big heatsink as well, so that's going to have the same cooling effect. Well, there we are, guys. I think that's about it for this one. As you can see, there's lots of wires, lots of thinking about how I'm going to route stuff and what have you. But at least I know what wires go to where and what they're for, and it all sort of works. All the bits I'm not used to. Obviously, I'm used to wiring up stepper motors, and I pretty much got that sussed now. Having done, how many? 1, 2, 3... 3 or 4 of them anyway. So yeah, I know the how to do and how to go about that. So anyway, yeah, just short, not a lot of machining, but just showing you that it is progressing, and these are all things I've got to do before I can start sort of stripping it down. Now, I do want to buy quick change tool posts for the lathe. I do want to buy an ER32 chuck that goes directly on the spindle. So that's a couple of bits I've got to order. Yeah, I mean, that's more for further on, but that's very similar stuff to what I've done on the Walko in the past, so shouldn't be a great problem with that. I haven't addressed the tailstock at all as it stands at the moment. I am planning on basically drilling through the tool post with this lathe, or using the tool post as a drill. So having a chuck mounted in a tool holder, having some sort of reference datum, that idea. But obviously, if I am doing long stuff, I pretty much would use the Walko. This lathe is going to be pretty much for the smaller, you know, little bits and pieces, more the sort of steam engine stuff, that idea. So at least I can leave a job set up and still have the Walko there that I can still use. So yeah, this will be a lathe I use. It will be set up on the bench. But again, it's going to be more for the small model making stuff where you know, I can rough the parts out on the Walco and then transfer them to this lathe and do the details and the small stuff on this lathe. So that's the idea and thinking behind having the second lathe. So yeah, I've never really touched on that before, but yeah, that's the thinking forward. I mean, I'm not looking at it being a watchmaker's lathe, let's put it that way. People ask the question, have you ever thought of making one of those? Don't do enough of it to warrant that. But yeah, I'd like to do a couple more steam engines and what have you. I think Matty at Matty's workshop, so hiya Matty, he built a little single cylinder petrol engine from scratch, from a sort of set of plans. And in fact, Matty, if you're watching, hit me up with that set of plans, can you? I have got that on the back burner for a future project, so I know we've had this discussion before, but I just keep forgetting to ask. I believe you have got my email. Anyway, it's on the beginning of the video. So anyway, I think I've waffled enough now, guys. So as usual, while I'm on the subject, we have passed the 12,000 subscribers, so thank you to all of you that subscribed recently, and to obviously the subscribers who've been with me many years and are still with me, so huge thanks for that. It's another milestone passed. Yeah, it's just another 1,000 ticked off the list. It seems to be a long time ago I hit 10,000 and it slowed up a bit, but then my projects haven't been that busy lately. I've had very little on the go other than this mini lathe, and obviously following on from the Stewart models. I'm waffling again, aren't I? I don't stop once I get going. Anyway, as per usual, thanks for watching, guys. Thanks for subscribing, and we will see you all very soon. Cheers now.